having in the first case, operating limits for power generation are not specified. So based on this flowchart, algorithm we have flowchart. So first one is step number 1, assign a initial trial value of lambda. So I already mentioned in the previous class, the lambda is nothing but your cost analysis function. So the lambda is calculated with the help of this equation. This P demand in power plus summation of I equal to 1 to n VI by 2AI whole divided by summation of I equal to 1 to n 1 divided by 2AI. So this is made initial trial value declaration equation. So here I have to fix my lambda. So in step number 2, I have to compute my generating power corresponding to the cost analysis. So this generating power belongs to the 3 factors. The sigma of I plus beta of I, where I is nothing but lambda of I of IC1 square. So I just replace C by lambda. So the generating increment I stands for increment. So PGI equal to del alpha of I BI beta I lambda gamma I lambda square. So while solving this equation, we get the generating power PGI. So PGI is nothing but lambda minus EI by 2AI. Where I stands for 1, 2 up to n number of functions. If it is the cost function is given, cost function கொடுத்தா மட்டும்தான் நம்ம வந்து இந்த PGI வந்து assign பண்ணணும். So step number 3, we have to compute our generated power in increment. That is I equal to 1 to n. So 1 to n buses. You have 3 bus, 4 bus, 6 bus, 8. Likewise, you have number of buses. So based on the number of buses, you have your incremented power, generated power. And in step number 4, the power balance equation. So the power balance equation is nothing but PGA equal to PD. So the generation meet out the demand, then only the power balance is satisfied. So in today's scenario, the demand is more and more, but the generation is comparatively demand is less only. So only we have power failure. So this power should be satisfied. We are performing this kind of analysis. Okay. So optimum solution is required means we have to proceed with your generation should be equating to your demand. Then only optimum solution is achieved. If it not achieved means we have to proceed with next step. What is next step? If I equal to 1 summation of n means PGI is less than PD. So this is the first case I have to analysis. The optimal is not obtained. Not obtained means I have to check whether it is greater or lesser. The first condition is lesser. I am checking. PGI is less than PD. So I have to increment my cost function lambda. That is lambda plus del lambda. I have to increment one step. This is one step. Next one, PGI greater than PD. So lowest possible permissibility I have to check, as well as highest permissibility I have to check. So 2 scenarios I have to evaluate. So whether it is higher or lower. So PGI is greater than PD. So in this case, your lambda is equal to del minus lambda minus del lambda. So decrement lambda. So if it is lesser means I have to increment my lambda. If it is greater means I have to reduce my lambda. So where del lambda is nothing but del P by summation of I equal to 1 to n 1 by 2ai. Or del P is nothing but change in demand. So these 5 procedure corresponds for your operating limits of power generation are not specified. So next we proceed with the case number 2. Case number 2, operating limit power generations, the production's cost function are given. So in previous case that is not given, not specified. In this case, the designer or the manufacturer specified the limits. So the compute lambda using the equation, the same equation I'm using. So in order to find out your lambda, PD plus I equal to 1 to n, EI by 2 AI, whole divided by I equal to 1 to n, 1 by 2 AI. So the lambda is common only. So step number 2 is I have to use my PGA using the incremental cost basis. So the economic surely PGA is del minus EI by 2, evaluated in the last case itself. So step number 2 is also same. So step number 3, I have to the limits of the generating power. So PG minimum less than or equal to PGA max. So I have to check the range of the maximum to minimum correlation. So P is equal to 1,2 up to n number of times. So after this applying, that means we have to proceed with the next step. So number 4 is PGI violation. The PGI violates the means I have the equation del mu minus PI by 2A. So PGI equal to PGI and PGI minus PGI max. So the two conditions should be satisfied. Here it is not displayed. The equation is PGI equal to PGI max and then PGI max. This is the violation. Range of equality greater or less. Now you have to redistribute the remaining system. So the new demand should be evaluated. Already I am having old demand. So PD old means sum of its generation to the remaining ones. Next step number 6, I have to compute my lambda new using the PD new and compute the remaining generation using my general equations. Next is I have differentiate one time for all the content. So the optimality condition is satisfied means I have to differentiate each and every terms one times. So dfi PGA by dPGA. So I make it the lambda new. So the operation limit is PGA minimum to PGA max. So next is dfi PGA by dPGA. So it is less than or equal to lambda nu. So for this is PGA equal to PGA max. Greater than or equal to lambda nu. PGA equal to PGA minimum. So if all the conditions are satisfied means you have to stop the process. Otherwise release the generation schedule except to whether minimum or PGA max of closing not a condition. So the PD new is a new one. Already we have PD old, PD new, and PD new one. So this is the demand. At the end of all the iteration process, I'm having demand. So PD new one, PD new plus sum of the generation not satisfying the optimality condition. So this is the corresponding algorithm, economic dispatch of within the limit or without the limit. So based on the algorithm, we have the flow chart. So starting process, read all your declarations. There's real power, reactive power, voltage, process, everything we have to read process. And we have to assume our lambda. Lambda is nothing but your general equation, PD plus summation of I equal to 1 to A by 2G, whole divided by summation of I equal to 1 divided by 2G. So next one is set your iteration count I equal to 1 and solve your power generation equation lambda minus BA by AI. And I have to check my maximum limit as well as minimum. So if PGI greater than PGI max means PGI equal to PGI maximum. If it is no means automatically proceed with the minimum value. PGI less than PGI minimum. So the setting value should be PGI equal to PGI minimum. So if these two conditions is not satisfied means I have to increment my iteration count again. So having my I equal to 1. So having set I equal to I plus 1. So if the increment condition is not stuck, I have to check my buses. I have to improve my buses. So when buses is improved, I have to calculate my change in demand power. So del P equal to summation of del PGI minus PT. Yes, I have to equate my del P is less than R. If yes means I have to generate generated power, cost of generation, calculation of power and stuff. If it is not means I have to increment my lambda again and again. Or otherwise I proceed with the initial process. You have to set the iteration count I equal to 1 again and compare your generating power maximum to minimum value. Again, you have to check your iteration process I equal to I plus 1, then count your number of buses. So it is a cyclic process. It is repeated till the optimum solution is achieved, the process is repeating. So it is a cyclic process. Clear? So the questioning So next one is integration of economic dispatch control with LFC mode frequency control. So my input is ACE. I am having my integral controller K by S. So after I am having my error vector, so this error vector is given to the speed change. So initial speed adjustments have to be done. The changed or modified speed is given to the governor. So from the governor, the turbine gets input. From the turbine, which is connected to your electrical generator, you may having your electrical power. Then it is product with your local EDC generator power. It is a feedback process. For example, if it is a hydropower station, so based on your water stream flow, the turbine may be rotated slower or faster. So it is a cyclic process. Here it is a control area. 1 area, 2 area, so that is the control area. So again, we have one more cases. So the integral is connected with the error director, speed changer, governor, turbine, generator, and localities. So the last step is once you achieve your optimal generating power, the process is repeated again and again, just like your flow chart. So EDC is nothing but economic dispatch controller. It is a microcontroller based process. Okay. And CEDC is nothing but your central economic dispatch. So the desired generation power is achieved or not, be able to check here. It's not achieved means we are doing the error correcting process again and again in order to ensure the optimal power flow solution. So this is the integration of economic dispatch control with your load. Let's control equipments. These are all the control equipments within the block. From area integral controller, EGA versus lambda, that is cost curve. We have comparator to actual to desired. And we have integral controller. The integral controller is connected with your speed changer. So within a single block, you have 3 components. You have function generator, you have comparator, you have integral controller. Next is the economic dispatch integration in a detailed manner. So EC1 minus KI1 by S integral controller. I am having my regulating signal is summed up. So it is connected with your governor, turbine, generator. So it is one input is your area 1, another should be your feedback. So EDC, PFC, again it will connect it to your regulating signal. So from your power flow controller, you have your station outputs, tie line loadings, one more tie line loadings, station outputs. So 2 tie lines are connected here. Area 1 to area 2 is mutually connected, and the 2 tie lines are connected mutually. Both directions are connected. So again in the bottom I'm having another integral controller regulating signal. Regulating signal is connected to the PFC, EDC, that is economic signal, summer, governor, turbine, generator. Before connecting to your area 2, I'm having my feedback. The optimum solution கிடைக்கிற வந்து இந்த ப்ராசஸ் எல்லாமே வந்து பார்த்தீங்கன்னா உங்களுக்கு ரிப்பீட் ஆகிட்டே இருக்கும். ஸோ இட் ஷுட் பி ரிப்பீட்டட் அகைன் அண்ட் அகைன். சரியா? So only the computer control is possible in a power system. Already வந்து மேனுவலாக இருந்தது. Now it is computerized. அதனால இந்த ப்ராசஸ் எல்லாமே வந்து பார்த்தீங்கன்னா ஆட்டோமேட்டிக்காக நடந்துகிட்டே இருக்கும். Now we have numerical examples. So first problem in this unit, the fuel cost of 2 units are given by F1 equal to 1.6 plus 25 Pg1 plus 0.1 Pg1 square rupees per hour. The first fuel cost. And second fuel cost F2 is 2.1 plus 32 Pg2 plus 0.1 Pg2 square rupees per hour. Total demand of 2 generators is given by 250 megawatt. So we have to find the economic load scheduling of the 2 units. Economic load scheduling means the generating power values we needed. So Pg1 we have to find and Pg2 we have to find. Okay. So the information is given as total generation is given 250. That is, we have 2 generators because 2 fuel cost is given. So we assume 2 generators is connected. So Pg1 plus Pg2 is 250 is given. Okay. So we have to find out the economic load scheduling of 2 units. So at what megawatt if we operating the power system, we may achieve our economic condition. Yeah. So lambda 1 வந்து பார்த்தீங்கன்னா we need to differentiate F1 with Pg1. F இருக்காங்க இல்லையா, வச்சுட்டு Pg1 dF1 by dPg1. So 1.66 on the constant. So 25 Pg1, 25, 0.1 Pg1 square, 2 into 0.1 Pg1. So 0.2 or so 25 plus 0.2 Pg1. அதே போல எனக்கு lambda 2 வேணும்னா dF2 by dPg2. So 2.1 is constant, it is vanished. 32 Pg2 around 32 தான் வரும். 0.1 Pg2 square na 2 into 0.1 Pg2. So economic condition is achieved when lambda 1 equal to lambda 2. So what is lambda 1? We have 2 equations, 25 plus 0.2 Pg1, which is equal to 32 plus 0.2 Pg2. Yeah. So I am bringing my Pg1 to the Pg1 Pg2 to the left hand side. Already I am having 0.2 Pg1 positive. So in the right hand side I am having plus 0.2 Pg2. If it is moved to the left hand side, negative sign. So minus 0.2 Pg1, 0.2 Pg2 equal to 7. 32 minus 25. So I have to bring my 25 here. So already positive here. If I am right hand side, it is negative. So 32 minus 25, 7. So for this equation, I divide thoroughly by 0.2. After terms, both left hand side and right hand side, now then 0.2 divide. So if I am dividing by 0.2, the answer should be Pg1 minus Pg2, 7 by 0.2. 7 by 0.2 is nothing but 35. So total demand in the problem itself given. Pg1 plus Pg2 equal to 250 is given. So I just adding the 2 equations. If I am adding the 2 equations, means 2 times of Pg1 equal to 285. And the plus Pg2 minus Pg2 get cancelled. Sada equation solve பண்றது தான். So 2Pg1 equal to 285. Pg1 equal to 285 by 2. So the answer should be 142.5 megawatt. So now substitute this value in your equation number 2. 2 means here. So if I am substituting, the PG2 should be 107.5 megawatt. So the optimal condition is achieved means your PG1 should be 142.5 and PG2 is 107.5 megawatt. So ஒரு 8 மார்க்ல 6 மார்க்ல கேட்பாங்க இது போல ப்ராப்ளம்லாம் கண்டிப்பா கேட்பாங்க. இந்த 4th யூனிட்ல வந்து பாத்தீங்கன்னா இந்த ஃபியூல் காஸ்ட் பேஸ் பண்ண ப்ராப்ளம் வந்து கட்டாயம் இருக்கும். 14A இருக்கும். எல்லா யூனிவர்சிட்டி क्वेश्चंस பார்த்தீங்கனாலும் இந்த ப்ராப்ளம்ஸ் இது போல ஃபார்மட்ல ப்ராப்ளம் இல்லாம இருக்காது. இது ஆல்டர்னேட் மெத்தட் கண்டுபிடிக்கிற ஆல்டர்னேட் மெத்தட் ஃப்ளோ சார்ட்ல பார்த்தோம் இல்லையா, PD plus I equal to N PI by 2AI whole divided by summation of I equal to 1 to N 1 by 2AI. 250 demand 25 by 0.2 plus 35 by 0.2 divided by 1 divided by 0.2 plus 53.5 you may achieve. So PG1 expansion should be lambda minus B1 by 2A1. So 142.5 megawatts you are achieving. And PG2 is lambda minus B2 by 2A2. 107.5. So alternatively you may achieve using the lambda equation. The solution is possible. உங்களுக்கு எந்த மெத்தட் ஈஸியா இருக்கோ அதை யூஸ் பண்ணுங்க. Next problem pa. First problem da prachana irukka? Do you have any doubts or clarification required in problem number 1? Da irundhuna kelra. Da doubt irukama? Adha problem pota. Okay. Shall I continue with the next problem? Second problem. The fuel cost of 2 units are given by F1 equal to 1.625 PG1. A power plant consists of 200 megawatt units whose input cost data are given by F1 equal to 0.004 P1 square plus 2.0 P1 plus 80 rupees per hour. Second fuel cost F2 equal to 0.006 P2 square plus 1.5 P2 plus 100 rupees per hour. So the total load is 250 megawatt. What should be the division of load between 2 units for the most economic operation? Same case only. In the same procedure only. So last case PG1, PG2 is given. In this case P1, P2. Like that, to provide the problem. So easier only, ma. So you have to differentiate once both the equations. That is lambda 1 equal to df1 by dp1, lambda 2 equal to df2 by dp2. When you're differentiating p1 square, so 2 times of 0.004 p1, 2 times of p1 is nothing but 2, 8 is constant 0. Likewise, lambda 2 df2 by dp2, 2 times of 0.006 p2 plus 1.5. So finally, lambda 2 is 0.012 p2 plus 1.5. So the incremental cost basis is lambda 1, which is equal to lambda 2. Just substitute here. 0.008 p1 plus 2 is equal to 0.012 p2 plus 1.5. Solve the equation. You make it the equation as p1 plus p2 is 25 given in the problem. Remaining, it is 0.008 p1 minus 0.012 p2 equal to minus 0.5. So we have two equations, solve it. So multiplying equation 2 by 0.012 in order to solve the equation. 0.012 p1 plus 0.012 p2 equal to 3. Now you add 1 and 3. If you are adding 1 and 3, p2 get cancelled because plus and minus. The remaining should be 0.02 p1 equal to 2.5. p1 is 25 divided by 0.02, 125 megawatt. Now substitute the value of p1 in the any one of the equation, either 3 or 1. Yeah, substitute பண்ணீங்கன்னா p2 கிடைச்சிரும். So p2 equal to 250 minus p1. So 250 minus 125, 125. So in both the power generations, the power rating should be 125 megawatt for the economic operation. ரொம்ப ஈஸியா இருக்கு சார் இந்த ப்ராப்ளம். எக்ஸாம்ல கேட்டாங்கன்னா கட்டாயம் ஜஸ்ட் டிஃபரன்ஷியேட் பண்ணிட்டு ஈக்குவேட் பண்ணிட்டு எனக்கு p1 p2 சால்வ் பண்ணா போதும். சரியா? இது போல சிம்பிளா தான்டா கேட்பாங்க, ரொம்ப டஃபாலாம் இருக்காது. ஃபியூல் காஸ்ட்டை பொறுத்தவரையும் உங்களுக்கு சிம்பிளா தான் இருக்கும். Next example, consider two systems shown in figure. We have two generators. There are no base loaded units P1 and P2, both being under control. So here you have your controllers. The units assumed to have the quadratic function of the type. How should the two units share the total load PD? இது வந்து ஒரு டெரிவேஷன் மாதிரி கேட்டிருக்காங்க. டேட்டாஸ் எதுவும் தரல, கண்டிஷன் தான் கொடுத்துருக்காங்க. So there are no base loaded units with the P2, both being under control. The units are assumed to have the quadratic cost function. So we have the two root based equation. So if I am having the quadratic type of equation, what is the load sharing? Whether it is equal or not, I have to check the analytically. So in case of cost function or constraint equation, E is nothing but C times of Pg1 Pg2 rupees per hour, and Pg1 plus Pg2 equal to Pd1 plus Pd2 equal to Pd. So this is my general equation. In the question, they clearly mentioned two generation variables. C represents your cost of phase in the three-dimensional space. So we have two units, generation 1, generation 2. So for generation 1, cost function is C1, and they said it is a quadratic function. So alpha 1 plus beta 1 Pg1 plus gamma 1 Pg1 square. Likewise for unit number 2 is C2. So alpha 2 plus beta 2 Pg2 plus gamma 2 Pg2 square. So now we need your cost function, lambda 1 and lambda 2. You have to differentiate one. So what is differentiate panina? So the dc1 by dpg1 is nothing but, so alpha 1 is constant. So with respect to pg1 means we have only beta 1. So 2 times of gamma 1 pg1. Likewise lambda 2 equal to dc2 by dpg2. Beta 2 plus 2 times of gamma 2 pg2. So you have to apply the condition of the optimal power flow solution. So lambda 1 equal to lambda 2, applying the equation. So beta 1 plus 2 gamma 1 pg1 equal to beta 2 2 gamma 2 pg2. So we know that pg1 plus pg2 is equal to pd. So from this I am getting my pg2. So pg2 equal to pd minus pg1. So now I am substituting the two values of equation 1 and 2 here. If I am substituting beta 1 plus 2 gamma 1 pg1 equal to beta 2 2 gamma 2 pd minus pg1. So we have a pg1 term in the both left hand side as well as right hand side. So just to bring out all the terms in the left hand side and taking pg1 as common. So pg1 of 2 gamma 1 plus 2 gamma 2 equal to beta 2 minus beta 1 plus 2 gamma 2 pd. So from this I may get Pg1. Pg1 equal to beta 1 minus beta 1 plus 2 gamma 2 Pd equal divided by 2 times of gamma 1 plus gamma 2 in megawatts. So similarly you have Pg2 also the same. So just beta 1 and beta 2 is traversing. அது மட்டும் தான் மாறப்போகுது, மற்றெல்லாம் சேம் தான். So beta 1 minus beta 2 2 gamma 1 Pd by 2 times of gamma 1 plus gamma 2 megawatt. So இதுவும் அடிக்கடி கேட்குற ப்ராப்ளம் தான். இந்த ப்ராப்ளம் அடிக்கடி நான் பார்த்துருக்கேன் உங்களோட யூனிவர்சிட்டி பேப்பர்ஸில். ஓகேவா? இது நியூமெரிக்கலாக கேட்காம டெரிவேஷன் மாதிரி கேட்டிருக்காங்க. இதுவும் ஈஸியாக தான் இருக்குது. ஸோ திஸ் இஸ் யுவர் தேர்ட் ப்ராப்ளம். நெக்ஸ்ட் வந்து பார்த்தீங்கன்னா ஃபோர்த்து ப்ராப்ளம். The power plant has 3 units. So far we discussed about 2 units. ரெண்டு பவர் ஜெனரேஷன் யூனிட் வச்சு தான் பார்த்துருக்கோம். இனிமேல் பார்க்க போகிறது வந்து பார்த்தீங்கன்னா 3 ஜெனரேஷன் யூனிட். ஸோ காஸ்ட் ஃபங்க்ஷன் வந்து பார்த்தீங்கன்னா F1ன்னு தருவாங்க, காமா 1 சாரி லாம்டான்னு தருவாங்க, இல்லைன்னா சீன் தருவாங்க. ஸோ இந்த ப்ராப்ளத்துக்கு வந்து சீன் கொடுத்துருக்காங்க. So C1 equal to 0.05 Pg1 square plus 23.5 Pg1 plus 700 rupees per hour. First cost function. Second cost function 0.2 Pg2 square plus 20 Pg2 plus 850 rupees per hour. And third cost function is 0.09 Pg3 square plus 18 Pg3 plus 960 rupees per hour. Maximum and minimum loading are available on each unit of 150 megawatt and 40 megawatt. So the maximum value should be 150, minimum value should be 40. So optimum scheduling of the load is 275 megawatt. So that is total Pg1 plus Pg2 equal to 275 megawatt. Yeah. So first we have to evaluate lambda. So lambda is nothing but Pd plus summation of I equal to 1 to n Pi by 2ai. So Pd is 275. So we have 3 functions, 3 limits we have. So 23.5 2 times of 0.05 plus 20 divided by 2 into 0.2 plus 18 divided by 2 into 0.09. So more function போட்டா அதே போல summation of I equal to 1 to n 1 divided by 2a in the denominator. So 0.05, 0.2, 0.09. That is 6.5. So the lambda is 36.55. Pg1, Pg2, Pg3 is lambda minus P1 by 2a1. So that is 6.55 minus 23.5 divided by 2 times 0.05. 130 we may achieve. Pg2 equal to lambda minus P2 by 2a. 6.5 is 29. 2 into 0.41 by 3. Pg3 is lambda minus P3 by 2a3. 0.55 minus 18 whole divided by 2 into 0.09. 103.02. So now check for the element PGL. So 40 to 150. So Pg1 value should be 130. It is lying in the range. Second should be your 40 to 150. It is also lying in the range. Third is not 3. It is also lying in the range. So optimum scheduling is possible with these values. That is the perfect solution for this problem. Yama. Everyone. I closed the attendance. Email join பண்றவங்களுக்கு attendance கிடைக்காது. So yeah, attendance close ஆயிடுச்சு. We have 20 more minutes. Touch up one more problem. One more problem. The problem முடிச்சுட்டு நான் class wind up பண்ணுறேன். So a plant has two generators supplying the plant bus, and neither is operated below 20 megawatt or above is 135. So maximum value, minimum value is given. 20 megawatt to 135 megawatt கொடுத்துட்டாங்க maximum minimum. So incremental cost with PG1, PG2 megawatt is, we have two fuel costs, DF1 by DPG1, DF2 by DPG2. One on the 0.14 PG1 plus 21 rupees per megawatt hour. And DF2 by DPG2 equal to 0.225 PG2 plus 16.5 rupees per megawatt hour. Economic dispatch, find the plant lambda when the demand equals 45 megawatt, 125 megawatt, 250 megawatt. So first case, I have to equate my demand equal to 45. So in this case, what is your lambda? So if I am solving for lambda, 23.15. Based on this lambda, find out PG1. So lambda minus P1 by 2A1, 15.4. So whether the value lies within the range or not, what is the limit is 20 and 135. Minimum is 20, maximum is 135. So it lies not lying within the range. 15.4 on the range. So PG1 less than PG minimum. So if it is a case, means I have to fix my PG1 equal to PG1 minimum. So 20 fix pannite, I have to find out the new lambda one, DF1 by DPG1. So 0.14 PG1 plus 21 equal to 2.3, 23.8 greater lambda. So இது வந்து நான் புது lambda 1 equation எடுத்துக்கலாம். So optimally condition satisfy ஆனா PG1 வந்து 20 megawatts ஆகும். So my demand should be 45, G1 is 20, 25 megawatt. So the optimum schedule should be PG1 equal to 20 and PG2 equal to 45. Second case, my PD is 125. So for the 125 case, I have to find out the lambda. 125 plus 21 by 0.14 for the first cost, 16.5 divided by 0.225 whole divided by 1 divided by 0.14 plus 1 divided by 0.425. So the lambda value should be 30.0616. So based on the lambda calculation, you have to find out your PG1 as well as PG2. Lambda minus B1 by 2A1, lambda minus B2 by 2A2. So two different powers you are achieving. The minimum limit and maximum limit is given 20 and 135. It is within the range only. PG1 வந்து அதே தான் இருக்கு, PG2 அதே தான் இருக்கு. ஸோ உங்களுக்கு வந்து எந்த ப்ராப்ளம் இல்லை. அதுவே லாஸ்ட் இயர்ஸ் பார்த்தீங்கன்னா ஒரு வேல்யூ வந்து பார்த்தீங்கன்னா உங்களுக்கு வந்து 15.4 ஒன்று, செகண்ட் வந்து பார்த்தீங்கன்னா 20 வந்து. அதனால அந்த ஆப்டிமம் ஷெட்யூல் இருக்கும். ஸோ இட் இஸ் லைஸ் வித்தின் த ரேஞ்ச் ஒன்லி. லாஸ்ட் கேஸ் இஸ் 250. ஸோ 250 வச்சுட்டு நம்ம லாம்டா கால்குலேட் பண்ணுறோம். 40.849. PG1 is 141.78. PG2 is 108.2. இதுவும் அந்த ரேஞ்ச் தான். கரெக்டா? So the optimum condition is satisfied. So you are having your PG1 of 135, PG2 is 1 megawatt. All the three cases given demand, one cases the optimal condition is not achieved, other two cases optimal is achieved. That's the conclusion. Okay, Uma. And the four problems are any doubt on the cake at market lama. This four problem, if you have doubt, you ask. நான் இதில் அனுப்புகிறேன்டா, டீம்ஸ் அனுப்புகிறேன்.